Alright, here we're back. Excuse me, we're back on our 45 project here. Haven't been doing much video because I've been working on making parts, mainly this piece here. So I get a bunch more of these made up, and they take about an hour to 2 hours to make. First one took about 3.5 hours. Second one took about an hour and a half, I think, so it should be a little quicker. Basically, it comes from a do-it-yourself kit, piece of 1.5" bar stock, and it looks like that when you cut it out. So this is heat treated, so it's hard to cut with, which makes it even harder to make. So you make it from that, drill a big hole in it, turn it down roughly, then you cut this piece on down. So then when you're all done, you cut it off with the cutoff, like I did right there, and then you go sand it in the back, and then we have our part. And I need to make these for every size of washer I have. So this here is the stack of washers we got. We got 32nd, 16th, 3/32 and 1/8 inch. So this particular one here is made for the 16th washer, which is this one. That happens to be the thickness of the inside of the lip right there, where the cage goes in. So that goes into there like that, and we have our bearing, goes in there like that. That's how it works. And then you have your cage, or cage erase, right here, which I turned down to be nice and smooth, and that goes on top. Here's your thrust bearing. So here's one all set up right here. So you can push on it as hard as you want. Still rotates real free. The stock thrust washers are right here, which is basically just rubs. That's pinned in right there. And then you have your bearing race right here. Rubs against that and eats itself all up. So you have to have a lot of in-play, like 18 to 22 thou in-play, so you got room for oil to get in there. If you have any kind of a thrusting on your crank, like from a belt drive or a misalignment chain, you'll eat this thing up in a heartbeat. Or if you use something like 2050 oil or something like that in there, instead of thick ass oil like 60 or 70 weight. So we're eliminating that by putting a thrust bearing in it right here. So a thrust bearing you can push on as hard as you want, it doesn't care. So that's what we're doing over here, but we have to make it all fit. So these are the Truett & Osborne stroker flywheels. This is a stock Harley flywheel. This particular one's been balanced. So basically we have our parts right here. Our adapter piece goes around the flywheel lip right here. I didn't cut these right, so it's trying to go on, but not quite right. I'm going to take about 2 or 3 more thou of the ID. Originally I wanted these to be pressed on, but now they're going to have to be removable because I have to play around with thrust washers. I don't know what I need. So these are the parts we need. These are the bigger what we're going to plan on using before. Before we're going to use these little small 1.25" ones because they fit the race right here real nice. The 3/8 ones are a lot bigger than what the race is. But you have to do that because you have to have the bearing to be able to go on the inside. Which dictated we had to go to a bigger size because we had to make room for this piece here. Because this does not fit inside of the stock over there. So that dictated other changes. And that's all because of the bearing races in here, which is on this flywheel. These go in here. You have to flip these upside down like this. And the bearings going from, they drop in like that. I'll do this a little differently. I'm just going to stick it in right side up for now, which is not how you would do it normally. You cannot have cage against cage. And we don't want it this way because see the bearing sticks above the surface because I cut the race down in lathe. And I cut off this much thickness so that makes room for the bearing in here and be flush like the stock cage was because there is no room for the bearings on a stock application. So am I bouncing around enough for everybody? So this goes on there like that. This piece here, which which is going to be pressed on and Loctited onto the flywheel. It'll be Loctited to the flywheel, so I should stay put. This here goes around the cage, but does not hold the cage. The cage is free to float a little bit for bearing walk, so it's not going to be loaded. It'll be pretty close to center. There's only a few thou clearance, but this won't be held exactly. So we're not centering off the cage. We're centering it off of the flywheel over here. Right here. This is what's doing the centering. Not this. I was going to try to do it this way, but I decided I didn't like that. So then you have your bearing. It goes on there like that. And your thrust washer. Now this thrust washer is what goes into the flywheel right here. Basically it's replacing this 78 thou washer right here. These come in 16th to 100 thou thickness, variable thickness, which sets your in play. So this one here is going to be our interchangeable washer. The problem is if you change this washer out, you have to make this piece here taller to support it. Otherwise it can flip off with clearance, drop down like that, and then chew up everything. That would be a bad thing. So I have to make different thickness of these for each time I change the washer thickness. What fun. So this is what it looks like all together. Same as the other one. So you got all your stuff in here. Now I have not cut the flywheel away yet here for a washer. This is going to get pinned just like this one over here is. I have to cut this flywheel out bigger for here. Up here. Because this is different than Harley. Harley just is a flat surface. It does not have this lip right here. So we have to pin the taper in this lip, but not this outer lip. So to put this bigger diameter washer in here, I'm going to have to cut the flywheel out for that. I'm going to make this a relatively tight fit, but not a press fit. I am going to make it better than this though, because this is pretty loose. See, I don't like that much clearance. That's probably 10 or 15 thou. I don't like that. We're going to make it a lot tighter. So I don't want this moving around too much. But this has to be able to remove this piece and our race piece over here. We have to be able to take this on and off the system right here so I can change out this piece and the washer as a pair so we can keep our end plates. Now with all this thrust bearing going on over here, we should be able to cut our end plate down to 8 or 12 thou. So you still have a little bit of give for the flywheels to flex back and forth, but not a lot. Now, I'm not sure how much I want to give it, but somewhere between 10 and 20 is going to be my number. So anyway, so this is how this all works here. This all has to be made up yet. I have not finished making the parts yet. We're going to have to put a hole here, a notch, in this heat-treated washer to go around this heat-treated pin. I got to cut the flywheel out. So I got to do all that. I got to figure out how I'm going to do that because I can't get these pins out, so I got to work around it. So that's going to be a fancy cutter I have to make in a lathe because I can't do it in the milling machine. So it'll be fun. So anyway, this all just pops in right here. It's just mocked up. So it's the same setup as we had on the other side. Same piece. So that's how it all works. Like I said, this is a 16th washer. That's what this particular one's made for. And that's supposed to be recessed into there like that. Now the cage has to recess around that because the cage sticks up above our surface over here. And there's no way of getting rid of that problem. I didn't want to cut the cage down. If I cut this side down, the roller gets shorter. If I cut this side down, there's nothing to hold the cage together because I'd have to cut it down to about right there where my thumbnail is. So there'd be no cross section left to hold the cage together. So if you look at it from the top view, if you cut away the outside diameter right here, about thickness of my thumb, you can see how that half of the bearing, the half of the material that holds the cage together would be cut off. So that would weaken the cage to the point that it would break most likely. So that's why we can't do it that way. So you have to think of how everything works when you're making stuff different than stock. So you see all that just drops in there really nice. And space in there. Outer wash. Oh, you have an outer washer. The race is the outer washer. This gems. Some brand new right side gems. So they're not all the same size. This one's a little bit tighter than this one. So anyway, that's what we're going to work on all that. So it's just a matter of making all these parts work. So the key is making these. I'm going to make all these up. The next thing I have to do, I'm going to have to take these thrust washers and make the sizes that I don't have, which are the ones that are in between these four sizes. And the 16th one is right there. So I got to make these like every 5th hour or so. So that means I got to take the bigger ones and grind them down to what the thin ones would be. Make them up, kind of like I did over here already. This one here is a 45 thousandths. This one here is an 80 thousandths. This was cut down for big twins I did, knuckleheads and stuff. Different videos, I think I had those in there I made for. So anyway, I got to get all this stuff made. Still a lot of parts to make up. I'm going to try to get this made by my friend with a CNC lathe. He can whip these things out pretty quickly and save me a ton of work. So instead of me spending an hour and a half to do all the job I need to do, because I have to notch and some other stuff, you know, at $100 an hour, that gets expensive making these. It takes an hour, hour and a half to make one. So I'll try to make it a little cheaper, get down something more reasonable price. These are the dimensions right here if anybody wants to make them. So this is basically, it's 1 3/8 OD. That's the outside of the diameter of this. That's the part that fits around the bearing, which is right here. The bearing's 1 3/80. Gives us 5 thou clearance. So that's a plus. Now the washers are actually a little bigger. They're like 85, so they get a little extra clearance on those. So that's not a problem. The bearing's the thin part. The next thing is the ID for here. So this is 1 1/8 inches. And it needs to be 1 1/8 inches, give or take a couple thou. So that's a 125 to 127 dimension right there. The ID of the bearing for here is 375 to 377, a couple thou extra. That gets that. The next ID to worry about is the one in here where the cage goes in, which is over here. So this here has to be able to flip in there and have some clearance. You can hear the clearance side to side. There's about 5 thou in there. So that's my next clearance, ID, which is this one. So it's 1 337 to 1 340. This is 1 330. So that gives me 7 thou to 10 thou clearance. So you have a little bit of float, so if the bearings are a little out of round or some reason, there's some float on this. It's not going to be locking the rollers up, because if you lock up the cage, the rollers lock up, you have lots of problems. Rollers are supposed to roll inside of parts, not slide. When they slide, they chew up, so you want to be binding those up. So that's our next dimension. Now the next dimension above that is it has to go around the cage. So there's a depth in there. So the depth is this one right here, which is 78 to 80 thou deep. That's the height of the shoulder from here to the outside edge, which you see right here when it goes around the cage. Now that's consistent for all of the parts we're going to make. Now the next problem is the special part that has to change with each washer. All these other dimensions are the same for all of them. Now this one here, it's 140 overall width because we have a 60 to 62 thou thickness right here. This edge right here where my thumb is. That's the part that sticks above the cage right here. And that, like I said, it was made to go with a 60 thou washer. So when this is all assembled, the cage is flush with the inside of this surface. So I'm going to have to make, every time I change this washer thickness here, I need to change that thickness of this backspace in here to compensate so the washer won't get loose and possibly bind up. Because if this binds up and drops down to the shaft like that, starts spinning orbitally in here instead of rotating like it's supposed to, it'll lock up the whole crank because there'll be no in-play in there. You're taking all the in-play out of the crank, so everything will just bind up real bad. So you don't want to drop down. You don't want to see if you don't have a little bit of a lip like I got right here. There's only about 10 thou there. Doesn't take much for that to pop over the edge, and then you would have 10 thou less clearance, and all this stuff would not work right. these rollers don't work right when this is being held center and it goes off the edge of the washer. You can see how that would be a problem. So we're going to have to make sure that that washer, or whatever, this piece here, always has material to support the washers and keep them from coming out. It's not really the washer coming out, it's going to be the bearing, because the washer's inside of here. But we'll have to work around that problem. So that's what we're going to worry about. And so that thickness there is going to change with the thickness of the washer. It needs to be relatively close. It can't be thicker, but it can be a little bit thinner. You know, if you're going to have 10 thou in play, we can have 10 thou less than whatever your washer is. So let's say this washer is 3/32, which is 92 thou, roughly 92, 93. You know, this here could be anywhere from 85 up to 90 pretty easily. You could probably even get it down as low as 85, but I don't want to get that low on, or not 85, excuse me, down to 80 on the thickness, but I'd rather keep it closer than further. So this number is going to vary it, which is going to vary overall height here. So instead of being 140, if you took this number and added 30 thou to it to make it 90, you'd have to add it over here, so that turned to 170. So that's the part you got to keep on track of here. And the washer is not going to come out like I was showing you before. It's going to be the bearing that's going to come out. The washer is being held on a flywheel. It's just easy to show it like that. But so obviously the bearing's a lot weaker than the washer is, so we don't want to be doing that. This is not how bearings are supposed to work like that. It's supposed to rotate. Like this one is concentric. So, alright, so that's where we're at. Still got a lot of work to do. It's going to be probably a week or two more before I can get these other parts made up. Meantime, I'll get the flywheels cut out in here. I'll probably show you me doing some of this stuff. Like I said, watching me spend hours and hours making these two parts here and figuring all this out is not what I want to videotape. I'd rather just show you what I do after the fact. That way you don't have all the boring stuff I'm doing to make it all work. And when we're all done, we're going to have all these bearings and stuff are going to be set up in here correctly, working over here like they're supposed to work. That'll be right there. That'll be right in there. This goes in here. There. It'll be just like that. This is what it looks like without the flywheel in it. This is what it looks like with the flywheel assembled. So it's just reverse. Because my fingers here would be the flywheel, and over here I'd be the case. So different way of looking at things, but same thing's going on. So anyway, that's how we're going to do it. So got a lot of work to do here yet. I'm going to figure it out. And if you want to know what parts I'm using, that's the bearing number. This is the thin washer, which is an A. B is next washer, then C, and then D. Number stays the same. So that's your 1 3/8 washers. And when you get an 1 1/4 washers like these ones are, they're different numbers. So I already bought a bunch of those, but I'm not using them. I had to use these. I had to order up all this stuff extra. It took another week to get all this stuff in. So whenever there's a design change after you bought a bunch of parts, you have to deal with it. So we're also going to be upgrading this crank here to a seal. Go inside of this. So this will go right in down inside of that. So we have to make room for all that too. So that's why I had to figure out my depths and all this stuff. So anyways, a lot of stuff to figure out. And what I don't know yet is what the assembled crank width is, so I know what washer I'm going to use. So I'm going to make it for the 60 thou, and then we'll make some of these extra spacers where they run off to. This piece. And then we'll probably wind up taking the 3/32 washer. This one, and we'll probably want to be cutting these down, making a bunch of different size ones. So like this one over here, I had 80 thou made. Was that one I made up? No, I lost it already. Yeah, it's floating around here somewhere. Too many parts. That's 3/32. Well, anyway, I already showed you what they were. This is one here that's been ground down. So I'll wind up making a bunch of these in custom thicknesses to do what I need to do. And we'll have it made up so you can either do it with a stock flywheel, or circular flywheels, because it's going to be the same. The parts will fit the same, but this one here you don't have to do any machining. This one here you have to do more machining. You can just bolt it in. This one you have to do machining. This one would bolt in. Anyway, so that's where we're at. So we'll be back another, I don't know, a few days or a week, whatever. We get further along, we'll show more work. So that's it for now.